So today we're going to look at how to write a sine function when it relates to the Ferris wheel problems. The first part of a function is our radius, and our radius is our given. So it should always be given to you in the problem. Occasionally it's going to be given to you as the diameter, and you would just have to divide that by 2. Because the diameter goes all the way around a circle and the radius is just half the circle. So remember that in our circle, the radius is from the center out. The next thing that it's going to give us is the angular speed. So occasionally this is given to us, but sometimes we have to calculate it. And when you calculate angular speed, it's always going to be 360 degrees divided by the time it takes for one rotation. So you want to be careful when you read the problem because if it says that it takes like 10 seconds to go all the way around, that's actually not something that you're going to fill in for seconds. That has to do with your angular speed. Because almost always your seconds is going to be your variable. That is going to be the thing that you're trying to find. So our variable is going to replace in there. And then finally, we have our center height. So if we talk about our Ferris wheel, we have our wheel and the height from the ground. This is our center height. So this is always given to us. And occasionally, you're going to get the highest point. So it could be your highest point minus the radius. Because if you recall, from here to here is your center height, and then from here to the top is your radius. So if you're giving your whole highest point, you would just take the highest point minus the radius to get your center height. So if we have a scenario here, and it gives us all of this information, a Ferris wheel with a radius of 50 and a center height of 65 feet takes 40 seconds to complete one rotation around, moving counterclockwise. I can go ahead and fill in the things that I know. So I have a radius of 50 feet. I have a center height of 65 feet. And it takes 40 seconds to complete one rotation. So I want to put it here in seconds, but really I'm trying to find how fast it's going to move. So I'm going to do 360 divided by 40, and I get 9. So 9 times x, because I want to find out the number of seconds. So if I were to rewrite this to make it look a little bit neater, I have 50 times sine 9x plus 65. And so this is what you guys have been doing to find the height, but now we're putting it together into our equation.